Have you ever looked up at the night sky and wondered, where do stars come from? How do they live? And how do they die? Stars aren't just twinkling lights in the sky, they are the engines of creation, the cosmic alchemists forging the very elements we're made of. Today we're diving deep into the majestic life cycle of stars, from their mysterious birth in the clouds of space, to their explosive ends that shape the universe itself. Buckle up, because this stellar journey is nothing short of breathtaking. What is a nebula? Every star's journey begins in a nebula, a vast, colorful cloud of gas and dust, quietly floating through the cosmos. These nebulae are the stellar nurseries of the universe, home to swirling hydrogen, helium, and trace amounts of heavy elements. Gravity works its silent magic here, drawing the gas together, tighter, denser, until suddenly something incredible happens. A spark ignites. A star is about to be born. As gravity pulls the nebula tighter, the center compresses and heats up. This is the birth of a protostar. No fusion yet, just a growing ball of gas, fighting against gravity, heating, spinning, preparing for something monumental. And then, boom! Nuclear fusion ignites. Hydrogen atoms fuse into helium, unleashing powerful energy. A new star has arrived on the cosmic stage. Once fusion stabilizes, a star enters the longest chapter of its life, the main sequence. This is where stars shine steadily, brilliantly for billions of years. Our own sun, a main sequence star, burning bright at the heart of our solar system. But stars come in many flavors, from cool red dwarfs to blue-white giants hotter than any furnace on Earth. It's a delicate cosmic tug-of-war, gravity pulling in, fusion pushing out, and for now the star holds its balance. But nothing lasts forever. Eventually, hydrogen in the core runs out, and the star begins to change. The core contracts, the outer layers expand, the star swells into a red giant, or if it's massive enough, a supergiant. It becomes enormous, cool, and reddish in hue. Betelgeuse, a familiar name, is one such giant, big enough to engulf the orbits of Mercury, Venus, Earth, and Mars combined. The star's end is near, and what comes next is both violent and magnificent: the supernova explosion. The star's core collapses, and then in a fraction of a second it explodes. A supernova, one of the most powerful events in the universe. For a few brief weeks, it can outshine an entire galaxy. This cataclysm forges elements like iron, gold, uranium, all the heavy stuff we find in planets and even in our own bodies. In death, the star seeds the universe with life. What's left after the explosion depends on the original star's mass. Medium-mass stars leave behind neutron stars, ultra-dense spheres, just a few miles wide, spinning hundreds of times per second. But the most massive ones? They collapse into black holes, regions of gravity so intense, not even light can escape. These cosmic remnants are the strange, mysterious echoes of stars long gone. And yet they continue to shape galaxies around them, from the cold clouds of gas in space to the raging brilliance of supernovae. Stars live incredible, dramatic lives, and in their death, they give back, spreading the elements needed for planets, life, and even us. Every atom of carbon, oxygen, and iron in your body was once part of a dying star. You are, quite literally, made of stardust. So the next time you look up at the night sky, remember those stars aren't just out there. They're in here too. If this cosmic journey moved you, leave a comment, hit that like button, and subscribe for more explorations into the celestial theory, where the mysteries of the universe become stories you'll never forget.